Welcome to the DIY Honda Garage channel. In this troubleshooting presentation, we will be focusing on DTC P0171 and DTC P2187, which are diagnostic trouble codes indicating that the fuel system is running too lean in a Honda Civic model from 2022 onwards. DTC P0171 pertains specifically to an overall lean fuel condition, while DTC P2187 refers to the same issue occurring when the engine is idling. These codes are stored in the Powertrain Control Module, PCM, when it detects that the long-term fuel trim, LTFT, is above a predetermined limit, indicating a possible deficiency in fuel supply or an excess of air entering the combustion chamber. The crucial components involved in this process include the mass airflow, MAF sensor, air-to-fuel ratio, AF sensor, fuel injectors, and the engine's intake system. The location of these components varies, but they are primarily situated under the hood in close proximity to the engine. The purpose of this presentation is to provide a detailed, step-by-step troubleshooting guide to effectively diagnose and resolve the issues associated with these DTCs. DTC P0171 and P2187 signify that the fuel mixture supplied to the engine is excessively lean, which can lead to performance issues and increased emissions. The long-term fuel trim, LTFT, is a corrective measure taken by the PCM to maintain the optimal air-fuel ratio. If LTFT exceeds a specified value, the PCM classifies this as an abnormality. The MAF sensor plays a pivotal role in measuring the amount of air entering the engine, which is critical for determining the required fuel quantity. It is usually located near the air intake system, connected to the intake manifold. Other components that can contribute to the lean condition include the injectors, which are responsible for delivering fuel, and the intake system itself, which must be free of leaks. Any of these components can fail or malfunction, prompting the PCM to activate these error codes. The potential causes for DTC's P0171 and P2187 include various issues within the intake and fuel systems. First, a leak in the intake air system can lead to unmetered air entering the engine, disrupting the air-fuel ratio. This might occur at joints between hoses, gaskets, or damaged components. Second, a malfunctioning MAF sensor may provide incorrect readings to the PCM, leading to improper fuel delivery. Third, fuel injectors may be clogged or failing, resulting in insufficient fuel reaching the combustion chamber. Lastly, issues within the positive crankcase ventilation, PCV system can produce unmetered air, further complicating the fuel mixture. Addressing these possibilities is critical for accurate diagnosis and repair. When facing DTCs P0171 and P2187, you may notice several symptoms that indicate the vehicle is running lean. The most significant indication is the illumination of the check engine light, which alerts the driver to a fault in the engine management system. Additionally, you may experience poor engine performance, characterized by sluggish acceleration and difficulty maintaining speed. Rough idling is also common, with variations in engine RPMs that can lead to vibrations. Lastly, increased emissions may result, as a lean mixture can produce higher levels of nitrogen oxides, contributing to environmental pollution. Recognizing these symptoms is essential for timely diagnostics and remedial action. For the first step in troubleshooting DTC's P0171 and P2187, it is crucial not to clear the diagnostic trouble code or reset the PCM before starting the inspection process. Clearing the DTC can erase valuable information that might be needed for effective diagnosis. Additionally, inspect any aftermarket fuel system or engine components, as modifications can introduce new variables that could lead to lean conditions. After these checks, it's advisable to review the How to Troubleshoot section for a detailed understanding of the procedures to follow. This foundational step prepares you for a more systematic approach. In the second troubleshooting step, start the engine and allow it to idle without any load. Ensure the continuously variable transmission, CVT, is in park or neutral, or the manual transmission, MT, is in neutral. Monitor the HDS, Honda Diagnostic System, to see if the AFFB ST fuel trim value exceeds 1.33. If it does, the failure is confirmed as duplicated. This procedure is critical in determining whether the condition exists under idle. Providing insight into the vehicle's performance issues. If the reading is within range, further inspection of components will be necessary. The third step involves reviewing the HDS onboard snapshot to collect data when DTC P0171 and or P2187 was initially set. Record the AFFB fuel trim values during this snapshot, as they provide crucial baseline information. Next, test drive the vehicle under conditions similar to when the DTC was triggered, ensuring that you check engine speed, vehicle speed, and other critical factors like the relative throttle position, RELTP, sensor and accelerator pedal position, APP sensor. If the AFFB fuel trim again exceeds 1.33 during this test drive, it confirms the persistent issue and provides a strong basis for further inspections. For Step 4, perform a visual inspection of the MAF sensor to ensure it is free from obstructions. Remove the MAF sensor/IAT intake air temperature sensor to check for lint, bugs, or other debris that may hinder proper function. Normal conditions dictate that the MAF sensor should be clean and unobstructed. If any foreign objects are found during this inspection, there is a high likelihood that they are affecting air measurement, which directly influences the fuel trim values. Should an obstruction be detected, address it before moving to functional inspections. Step 5 involves functionality testing of the MAF sensor while the engine idles. Start the engine and ensure the HDS ECT, engine coolant temperature sensor, is above 158 Fahrenheit, 70 degrees Celsius, and all electrical loads are off. Hold the engine speed at 2,500 RPM for a duration of 30 seconds, while verifying the HDS MAF sensor values. Of critical importance, these values should ideally range from 4.1 grams per second to 5.7 grams per second under these conditions. If values are outside this range, it suggests a failure in the MAF sensor functionality, warranting further investigation or replacement. In Step 6, you will inspect the intake air system thoroughly for potential leaks. Focus on connections between the air cleaner housing and the intake manifold, as these areas are common leak points. Typical factors leading to leaks include poor connections, improperly installed components, and damaged parts such as hoses and gaskets. Low pressure in the intake system could indicate a serious issue that hampers performance. If the inspection reveals no leaks, it's safe to move forward. However, if leaks are found, they must be addressed before proceeding with further troubleshooting. Step 7 involves inspecting the PCV System 1 for any signs of leakage. A failing PCV valve or damaged hoses can introduce unmetered air that leads to lean conditions. Check all connections meticulously for proper seating and signs of wear or damage. Solutions may include reseating connectors or replacing faulty components. Confirming that there are no leaks is essential at this stage to ensure the system can effectively manage crankcase gases. A thorough inspection allows for addressing issues early and prevents further complications. In Step 8, you will inspect the PCV System 2, comprising several components including the PCV valve, hose, oil filler cap, and dipstick. Ensure that all connections are secure and examine these parts for signs of damage or wear. Just like in the previous step, the presence of leaks can lead to incorrect air-fuel mixtures, which in turn can trigger DTCs. Confirming that the system is sealed is vital, as a broken or poorly seated component can significantly detract from engine performance. If the inspection results indicate that everything is intact, you can continue with the diagnostic process. Step 9 requires inspecting the brake system for potential leaks, which could also impact engine performance. As with previous inspections, be vigilant for poor connections at hose and pipe joints or other compromised components. The brake system's functioning affects engine vacuum, and a leak could lead to unmetered air entering the intake manifold, contributing to the lean condition. If no issues are detected during this inspection, you can be assured that the brake system is functioning correctly. Should any leaks be discovered, however, corrective action will need to be taken immediately. For Step 10, you will examine the evap purge system for leaks, which can also introduce unmetered air into the combustion process. Just as in earlier steps, thoroughly inspect all connections and components associated with the evap system. Leaks in this area can lead to inefficient fuel usage and increased emissions, encouraging a lean fuel condition. Ensure that there are no visible signs of damage to components, as maintaining a sealed system here is crucial for optimal vehicle performance. If this area is confirmed to be leak-free, you can move ahead with further testing. In the 11th troubleshooting step, you will inspect the TC bypass system for leaks that can impact air intake and subsequently the air-fuel mixture. Take the time to check connections meticulously to ensure they are secure and free of damage. As with other components, leaks within this system can lead to an excess of air, influencing the fuel trim negatively. Careful examination is vital. Should leaks be discovered, these must be addressed to effectively restore optimal performance. Confirming that the TC bypass system is leak-free is an important step towards resolving the DTCs. In Step 12, proceed with a fuel pressure inspection, which is critical to ensure that the fuel system is delivering adequate pressure. Start the engine and hold it at 3,000 RPM without load until the radiator fan activates. Then, allow the engine to return to idle. Utilize the HDS to execute the direct injection fuel pressure test. The results should indicate normal fuel pressure levels for effective engine operation. If the results are abnormal, it suggests issues with the fuel supply system, and further investigation into DTCs P0087 and P0088 might be necessary. For the 13th step, the attention turns to fuel quality, given its impact on engine performance. Since there's no direct method to test fuel conditions, replace the existing fuel with known good fuel to evaluate if the previous issues persist. Draining the existing fuel completely and refilling with high-quality fuel can help rule out contamination as a factor in the lean fuel condition. If symptoms persist after using known good fuel, it suggests issues may lie elsewhere, while rectifying the problem indicates that the fuel could have been at fault all along. In the 14th troubleshooting step, focus will shift to the AF sensor, which plays a crucial role in adjusting the fuel mixture. Install a known good AF sensor, Sensor 1, and observe if the failure reoccurs during operation. If the DTCs return with the new component, this suggests that other related components may be faulty. But if the issues resolve, it is clear that the AF sensor was the root cause of the problem. Maintaining the integrity of this sensor is vital, as it allows the PCM to accurately gauge and adjust the air-fuel ratio for efficient engine performance. The 15th step targets the injectors, crucial for ensuring the proper fuel delivery into the combustion chamber. Replace existing injectors with known good units and monitor for replication of symptoms. If the failure persists, it indicates that other factors may contribute to the DTCs, necessitating deeper diagnostics. Conversely, if the issue resolves, this suggests an injector fault that warrants further scrutiny or replacement. Understanding the injector's role in the fuel system is essential, as proper function directly correlates with engine performance and emissions. In the concluding troubleshooting step, inspect the Powertrain Control Module, PCM, as it is responsible for managing various engine functions, including fuel injection and emissions control. If all prior check results indicate normal functionality, the conclusion may point to the PCM as the root cause of the persistent DTCs P0171 and P2187. Diagnosing the PCM itself may require specialized equipment or knowledge, as issues can arise from software or hardware malfunctions. Confirming that the PCM is functioning properly is critical, as it ultimately governs the vehicle's operational parameters. After completing repairs and component replacements, it's imperative to conduct a final verification to ensure that the issues have been resolved. Use the HDS to perform a retest and confirm that no DTCs are present, thereby validating the success of interventions. Also, test the vehicle across various conditions, including different speeds and loads, to ensure that the original symptoms do not reappear. Proper documentation of these tests is crucial for comprehensive service records. This final verification step ensures that the vehicle operates correctly and meets all emissions and performance standards. To prevent the recurrence of DTCs P0171 and P2187, engaging in routine maintenance is essential. Regular inspections of components like the MAF sensor, AF sensor, and fuel injectors can help identify issues before they escalate. Additionally, any damaged or worn parts should be replaced immediately to maintain optimal engine performance. It is also crucial to use high-quality fuel, as poor fuel quality has the potential to clog injectors or disrupt combustion. Establishing a proactive maintenance routine keeps your Honda Civic in peak condition and minimizes the risk of future trouble codes. In summary, DTCs P0171 and P2187 indicate a lean fuel condition that requires thorough inspection of the intake, fuel, and associated systems. Troubleshooting steps involve a systematic examination of components such as the MAF sensor, fuel injectors, and PCV systems for leaks or failures. The importance of regular maintenance cannot be overstated, as it is vital for preventing future issues and maintaining vehicle performance. By following the troubleshooting procedures outlined in this presentation, mechanics can effectively diagnose and resolve these error codes, ensuring the reliability and efficiency of Honda Civics from 2022 and onwards. Please like and subscribe to the channel. See you next time.